professors, and fellow students. Hello everyone! We are Group 5. Our project title is FoodScan, an AI-based food image recognition system. To help users quickly obtain food information and perform management tasks. Next is our team member introduction. Our team consists of 6 members: Lin Xiangxian, Zhang Ziding, Zai Yiaryu, Wu Sanlian, Gao Peilan, and Wen Mingjin. Special thanks to our advisor, Professor Ho Young-kong, for providing us with much valuable advice and guidance throughout the project. Thanks also to the team for the cooperation and discussions that allowed this project to be completed successfully. Today's presentation covers background and motivation, technology and methods, system design, system value, and finally, system demo and conclusion. As ready-to-eat and processed foods become more common, consumers in their daily lives rely heavily on the label information found on food packaging. However, food label content is usually information-dense, inconsistent in format, and lacks structure, making it hard for users to grasp key information in a short time, which affects judgment and efficiency. Therefore, this project is dedicated to using image recognition and AI technology to automatically extract and organize food label content, enhancing information comprehension and application value. Currently, food information faces 3 main problems. First, labels are difficult to read, being complex and inconsistent. Second, expiration management is difficult, as users often forget about their food items. Third, there is a lack of integrated tools, requiring users to use multiple apps for management. Consequently, we propose 3 research objectives. First, use AI OCR technology to automatically recognize text on food packaging. Second, convert recognition results into structured data for easier subsequent management and storage. Third, provide food logging, expiration reminders, and allergen alerts. Next, we will introduce our technology and methods. The overall workflow is divided into 4 steps. 1. User takes a photo or uploads a food image. 2. AI OCR converts the image into text. 3. AI models perform semantic analysis and data organization. 4. Results are presented in the system with management and reminder functions. Regarding technical architecture, we adopted a decoupled front-end and back-end design. The front-end is developed with Flutter, handling the user interface and operation flow. The AI portion includes OCR and LLM. The back-end uses Firebase for data storage and user authentication. First, AI OCR technology converts food images into text, such as ingredients and nutritional labels, turning difficult-to-process image data into analyzable text data. After obtaining the text, we use rejects for fast extraction of product names and expiration dates. Improving processing efficiency. Finally, an LLM performs semantic analysis to convert fragmented text into complete and structured data by integrating OCR, regex, and LLM. We can improve efficiency, accuracy, and data integrity, overcoming the limitations of a single technology and allowing the system to handle more complex food information. Now, let's move on to the system design section. We adopted a modular architecture for the system design, allowing functions to be developed and maintained independently, while also emphasizing system scalability and stability. We used a phased processing strategy. Starting from image input, it passes through a IOCR regex and LLM processing, finally outputting structured data. This workflow gradually improves data quality and accuracy at each stage. Next is our system optimization process. In the VO stage, the system mainly used a IOCR with regex to first convert images to text, then extract fixed fields like product names and dates. This method is fast, but limited to handling data with fixed formats. When data is irregular or has missing parts, accuracy is affected. Therefore, in V1, we added semantic analysis, allowing the system to understand content rather than just extracting text, improving its ability to process different data formats. In subsequent optimizations, the system evolved from V2 to V3. In V2, we added data standardization, such as using opens for simplified to traditional Chinese conversion, making the data format more consistent. Then, in V3, the system was further integrated and optimized, including structured output, date optimization, and multi-source integration. This not only made the data more complete, but also directly applicable to the front-end app, improving overall accuracy and stability. As you can see from the chart, the system accuracy gradually improved from 40% to 85%. This shows that technical integration and optimization can significantly enhance system performance and reliability. Next, let's introduce the system value. In our competitive analysis, we compared our system with Google Lens and MyFitnessPal. Google Lens focuses on image recognition, but lacks subsequent management functions, while MyFitnessPal requires users to enter data manually. Our FoodScan integrates both recognition and management, providing a more complete solution. This system solves data processing issues and improves efficiency, while establishing a complete food management workflow. The three major features of this system are AI technology integration, full process automation, and high accuracy. These features effectively reduce user operation costs and enhance the overall user experience. For the interface design, we emphasize simplicity, intuition, and real-time feedback, including the home overview and recognition screens, as well as the food logging and management interfaces, and the notification interface. Finally, we have the user settings interface and the pop-up notification when opening the app. Now, we will proceed with the system demo and conclusion. A video of our system in operation will be played here, demonstrating the actual workflow and functions. Now starting the app demo. We use Google accounts for login. After entering the main screen, a food reminder pop-up will appear. In the Home section, it displays the user's name and the number of expired or nearly expired food items. There are 3 quick actions here. It allows you to jump to your desired screen. Now, let's perform food recognition. You can crop the image here. But for this recognition, we will use the original size. During the OCR recognition process, since image processing and text analysis are required, the system displays a waiting animation to let the user know the system is still working and to prevent them from thinking the program has stopped. Here are our recognition results. Then we can save them. You can set the product name and date yourself. We'll set it to April 30th at 12 o'clock and save. It shows here. Food dietary restriction markers. Moving to the notification part, you can see more intuitively. Expired food and food that is about to expire. Finally, the settings part. The number of expired items is shown. And for the reminder days, you can set how many days before expiration you want to be reminded. In the Health and Blacklist section, users can configure settings based on dietary restriction markers. For example, detecting sugar, sodium, or salt. Users can use these food restriction markers to create a health blacklist. We'll set chocolate. During the food recognition process, the system automatically identifies keywords to highlight the ingredients the user wants to watch out for. That concludes our app introduction. This project successfully integrates AIOCR rejects and LLM technologies to establish a complete food recognition and management system. We will continue to improve recognition accuracy in the future and expand into more functions, such as nutritional analysis and commercial applications. The above are our references. This concludes our group project presentation. Thank you, professors and classmates, for listening.